So before talking about hypothesis testing for population proportion, let us review what we learned about confidence interval for population proportion. What's the difference between them? In analyzing the confidence interval for population proportion, we started by saying that, well, what do we need? We need to find a point estimate. Point estimate. The point estimate p hat is equal to x divided by n. What is x? X is the number of successes in your experiment, and n is the sample size. So this is the number of successes that we have, and n is the sample size. Well, after finding the point estimate for population proportion, which is the sample proportion, we move on to the next step. In the next step, we are interested in knowing what is the confidence level. So this confidence level might be 90%, 95%, 99%. This is the requirement from a person who are doing the project for. We need to know this. If there is no confidence level given, you always select 95%. In the third step, well, after finding the confidence level, we need to find the critical value. To find the critical value for each confidence level, we deal with a normal distribution. We have a normal distribution depending on what the confidence level is. The area is going to be 1 minus c divided by 2. Then we use our calculator. We go to second Morse. We find inverse norm, and then we enter these information. First of all, for the area, we enter 1 minus c divided by 2, depending on what c is, and the mean is going to be 0, and standard deviation is 1. After finding the critical value, ZC is going to be the absolute value of the inverse norm that you're finding. It must be positive number. Very good. After finding this positive number, the critical value, you move on to the next step. Well, you need to find something that we call the margin of error. To find the margin of error for population proportion, E is equal to ZC times square root of P hat 1 minus P hat divided by N. Well, after finding the margin of error, we construct the confidence interval, which is P hat, what we built from the first step, minus what we built from the fourth step, margin of error, and P hat plus the margin of error. Well, remember that finally you have to interpret this result. You're going to say, hey, I am C 90%, 95%, 99%, I am blank percent confident that the population proportion P is within P hat minus E and P hat plus E. This is the conclusion that you need to write at the end of your report. Well, this is for confidence interval. It gives us an approximation for population proportion. Sometimes we have a claim and we are interested in constructing hypothesis testing for population proportion with different steps than the confidence interval. So what are the steps in constructing the hypothesis testing? Well, in forming the hypothesis testing, the very first step is going to be checking to see if normality is met. Normality. Normality is n times p must be larger than equals to 5. N times 1 minus p must be larger than equals to 5. In the second step, you're going to build your null and alternative hypothesis. What is null hypothesis? What is alternative hypothesis? One of these is going to be given in the question, and you're going to build the other one. Sometimes null hypothesis is given in the question, and you're going to construct the alternative hypothesis. Some other times, the alternative hypothesis is given to you, and you're going to build the null hypothesis. So what are the key words? To construct null hypothesis, in the question, we're looking for equality. Larger than or equal to. Less than or equal to. Your null hypothesis always include equality somehow, either in the form of equal to is, some other times it is larger than or equal to, some other times it is less than or equal to. So if you have equality as your null hypothesis, you can quickly build your alternative hypothesis. The opposite of equality, not equal to. The opposite of larger than or equal to is less than. The opposite of less than or equal to is larger than, greater than. Okay, after constructing the null and alternative hypothesis, we need to identify the level of significance. Okay, 3. What is the level of significance, or alpha? Guys, do not confuse the level of significance, but confidence level. Confidence level, they say that, hey, you're 90% confident, 95% confident, 99% confident. The level of significance is a value which is 1%, 2%, 3%, 4%, 5%, 10%, small percentages, small areas that help us to identify the rejection region, rejection area. After identifying alpha, or level of significance, in the next step, we need to find the critical value or critical values. Critical values. But how do we identify critical values? That depends on the behavior of our alternative hypothesis. So I'm going to erase this part of the board and write it down for you here. So for critical values, if your alternative hypothesis, guys, it's important. I'm not working with null, I'm working with alternative hypothesis. If my alternative hypothesis says, hey, population proportion is not equal to a number like K, then the graph is called two-tailed graph. I have two tails for this graph. Well, one part of the area, this is 1 minus alpha divided by 2 is on the left, and 1 minus alpha divided by 2, actually it's just alpha. Alpha divided by 2 is on the right hand side.